In 2000, fossil preparator Bob Harmon was eating his lunch in the Montana Badlands when he spotted a chunk of fossil bone jutting out from the rocky slope above him. The bone would turn out to be the femur of a Tyrannosaurus rex, and it was just the first of many fossils to be found. By the end of the excavation, the team had recovered almost 40% of the skeleton, including most of the skull, along with several vertebrae and limb bones. This individual was nicknamed Bob Rex, or B-Rex for short, in Harmon's honor. And this find would start to fill a huge hole in our understanding of dinosaurs. Because while we like to think we know a lot about them, like how they moved and what they ate, for a long time, we haven't been able to ID one seemingly basic thing about their biology. Which dinosaurs are males and which are females? In the case of B. rex, scientists would have to crack the fossils open and look inside to find the answer. While scientists often give fossils nicknames like the famous T-Rexes Sue and Stan, we rarely actually know whether to call these individuals male or female in sex. And in this script, we'll be using male and female as shorthand for sperm-producing and egg-producing individuals. Being able to recognize these traits from fossils is actually important for understanding dinosaurs as living animals rather than as movie monsters or museum skeletons, because it can give insights into their behavior. One way paleontologists have tried to figure out the mystery of dinosaur sex is by looking for patterns of features across skeletons of the same species to see if they can be easily split into two groups, one group having the feature and the other not, for example. And this is because many of the close living relatives of dinosaurs are sexually dimorphic, which means there are differences in the physical appearances of males versus females. Like size, for example. Some species can vary significantly between sexes, with the sperm-producing males often being larger than the egg-producing females, usually so the males can physically compete with other males for mates. Or like the flashy feathers that male peafowl use to attract the attention of the more drab-colored females. But sexual dimorphism doesn't always mean bigger and more brightly colored males. In some species, like red-eared slider turtles, the females are actually bigger, so their bodies can hold more eggs. And in spiny-footed lizards, the adult females are the ones with vibrant red tails that the males seem to prefer when selecting a mate. So what might be a trait associated with males in one species could actually be a trait associated with females in another. And an animal's sex can tell us a lot about their behavior and reproductive strategies. Females often make a small number of large eggs, so they tend to have the most reproductive success when they are choosy about who they mate with. Males make a large number of tiny sperm, so they tend to have greater reproductive success when they stand out enough to be chosen by females as mates. So being able to identify sex in dinosaurs could reveal a lot about how they lived. In the 1990s, some paleontologists hypothesized that female T-Rexes could be recognized by the shape of their pelvis, and that they might be the bigger sex, like the red-eared sliders. But they didn't know for sure. See, for living animals, one shortcut for assigning sex to an individual is by their reproductive organs. Sperm producers have testes, while egg producers have ovaries. But for dinosaurs, we don't have that luxury. Soft tissues like skin, muscles, and organs usually decay away long before they can fossilize, making them pretty rare in the fossil record. So far, the closest we've gotten to fossilized dinosaur reproductive organs is a remarkably preserved Psittacosaurus cloaca, which is a single opening used for both reproduction and expelling waste. But even this incredible fossil didn't preserve the internal anatomy, like testes or ovaries, that we would use to call this animal male or female. And it's possible that some dinosaur species were sexually dimorphic, because we do see variation. But without knowing for certain the sex of any individuals, it's hard to say whether particular traits are linked to sex at all. Because the variations we see could be the result of sexual dimorphism, or they could be something else entirely. Like age-related changes, for example, or even just the normal variation that exists within a species. Maybe the differences even sometimes mean that we're dealing with two dinosaur species entirely. What paleontologists really needed was an independent line of evidence that linked a dinosaur skeleton and its sex, one that didn't rely on subjectively interpreting variation in the bones. what if the difference between male and female dinosaurs could be found deeper within the bones? In 2002, when B-Rex was being excavated, the team faced a unique challenge. See, the site was located in some pretty rugged terrain with no roads, so the field crew had to transport the fossils out by helicopter. And the biggest bundle, containing B-Rex's legs, ended up weighing over 900 kilograms, which was just over the helicopter's weight limit. So the team carefully separated the block into 2 sections. And in this process, a femur from B-Rex was split, resulting in several fragments of bone coming loose. Now, a broken dinosaur fossil might sound like a nightmare, but to paleontologists who study the internal structure of fossils, it's a dream. Like paleontologist Dr. Mary Schweitzer, who's made a career of looking past the surface of fossil bones, delving deeper to examine their complex internal structures. When she looked at fragments of B-Rex's femur under the microscope, she recognized something that could help solve the question of how to tell a male dinosaur from a female, at least for this individual. What she saw was a type of bone tissue called medullary bone, which is a unique spongy tissue found inside the bones of modern birds. It's produced when they're getting ready to lay eggs, and it partially fills in the air pockets found in the center of bird bones that make them light enough to fly. It acts as a readily available source of calcium for building eggshells. Now, Schweitzer had studied bird biology throughout her research to better understand the connection between birds and their non-avian dinosaur ancestors. So she was very familiar with medullary bone. So to try to determine whether what she was seeing in B-Rex's femur was really medullary bone, she compared it to bones from ostriches and emus that had died during their egg-laying cycles. And the porous, irregular structure of the ostrich and emu samples was nearly identical to the structure she saw in B-Rex samples. This was potentially a really big deal. It seemed like a surefire way to tell the sex of a dinosaur. Or at least, this dinosaur. Because if Schweitzer was correct, then Bob Rex was actually a female. And not just a female, but one that had been pregnant when she died. While many had suspected that theropod dinosaurs like T-Rex produced medullary bone, just like their avian descendants, no one had ever found it before. And this made for a pretty heated debate that isn't even fully resolved today, with a number of paleontologists proposing and testing alternative hypotheses to explain the funky-looking bone. Like in 2009, researchers described samples of diseased bone tissue from a turkey vulture and a Cretaceous dinosaur from Transylvania. And they noted striking similarities in appearances between these samples and those of B-Rex. They suggested that what Schweitzer saw in B-Rex was possibly the result of a bone disease called osteopetrosis, which affects many modern birds. These researchers also argued that big dinosaurs like T-Rex may not have needed medullary bone in the first place. See, it's thought that medullary bone in birds may have first evolved as a way to compensate for their thin-walled bones, because pulling calcium from the already light, delicate bones could cause those bones to easily fracture. So medullary bone provides them with a source of calcium for egg laying without putting their bone structure at risk. But this isn't necessary for egg layers with thick bones like crocodiles, who pull the calcium from their eggshells directly from their skeletons without any ill effects. And since the bones of T-Rex were fairly thick, the researchers suggested that these dinos may not have had medullary bone at all. Then, in 2014, a new aspect of the debate emerged when a study reported finding another example of medullary bone-like tissue in the lower jaws of several pterosaurs. Now, pterosaurs are thought to have laid eggs with very thin, leathery shells, which don't need much calcium. So this study challenged the link between medullary bone and egg production. At the time, it was also believed that medullary bone was produced almost exclusively in limb bones. So if medullary bone-like tissue could be found in pterosaur jaws, the researchers suggested, it may have had another purpose beyond egg laying. If this was true, it would mean that it couldn't be reliably used to identify pregnant individuals. So the debate raged on. Did B-Rex really have medullary bone? And do we have a way to recognize female dinos or not? To make a stronger case for the B-Rex medullary bone being the real deal, Schweitzer and her team had some more work to do. And in 2016, they published a study that analyzed the B-Rex bone at the molecular level, directly comparing it to the unique chemical signature of bird medullary bone. To do this, they applied stains that react with certain types of molecules found only in medullary bone. And the samples of the supposed B. rex medullary bone did react, becoming stained in dark brown and blue, just like the medullary bone samples from a hen and an ostrich. They also applied the same stains to samples of chicken bones with osteopetrosis. These samples didn't react, suggesting that the B. rex samples wouldn't have reacted either if the bone was just diseased. And in 2019, Schweitzer collaborated on another paper that revealed that birds in their egg-laying cycle can actually produce medullary bone in almost all areas of their skeletons, including the lower jaw. Which means that we can't yet rule out the role that medullary bone plays in reproduction based solely on where in the skeleton it's discovered. So where does the debate stand now? Well, these analyses did persuade many scientists of the usefulness of medullary bone for potentially identifying mature female dinosaurs, but some paleontologists still aren't convinced. And a new paper came out while we were working on this episode that found variations in a sample of 61 ornithomimosaurs from the same herd that all died together that looks consistent with sexual dimorphism. So there are other approaches researchers can take to try to ID the sex of dinosaurs, if they have just the right sample. What it all comes down to is that understanding certain aspects of dinosaur biology is more complicated than it seems, even for dinosaurs as well known as T-Rex. And with every hypothesis we test, we come closer and closer to understanding what life would have been like for these dinosaurs. Just like dinosaur biology, dinosaur mating behavior has been the subject of a lot of speculation, but what can we actually say about it from the fossil record? Check out our episode How Dinosaurs Coupled Up to learn more. Don't forget to be awesome like this month's Eontologists. Jake Hart, Raphael Haas, Annie and Eric Higgins, John Davidson-Ing, Melanie Lamb Carnevale, Addie, Tony Dye, and Juan M. You can become an Eonite at patreon.com/eons and get fun perks like submitting a trivia question for us to read. Here's one from Zizabizza. What's the name of the material or landform left behind when a glacier or ice sheet starts to recede? Our patron wanted a question about Indiana geology, and Indiana has this stuff. Is it glacial moraine? Or unless they're talking about the shredded rock that is left behind, which is glacial alluvium. The moraine is like the actual ending point part, but the alluvium is just the like crushed up rocks. Probably. Oh gosh, I teach geology. Put your guesses in the comments and be sure to stick around after the blooper to get the answer. And as always, thanks for joining me in the Adam Lowe studio. Subscribe at youtube.com/eons for more meanderings in the Mesozoic. She compared it to bones from ostriches and emos that had died during their egg-laying cycles. I said emos. Yeah. Well, I'm going to emo night tomorrow, so that's kind of on my mind. Okay. Whew. Great. The answer to the trivia question is moraine or till. Let us know if you got it right. I can keep teaching geology. Ha.